And it's recording. Here we go. Exercise 5G. You are doing the solution of exponential equations. Now, you've done some where maybe some of them you've already remembered from the VCA questions, where I got you to try to think of quadratics. How would you make it into a quadratic? So let's have a look at this one. This is exercise 5G, question 1C from your textbook. You've got a log e of 7 minus an x log e of 14 equals to 1. The goal is to find the value of x. All right. X is over here. And we're trying to get x by itself. So again, using your log rules or what you know, how do I rearrange this equation? So I'm just going to rewrite it again. Log e of 7 minus x log e of 14 is equal to 1. How do I solve for x? What would you do? Rango.
I'll move the x to the 14. So 14 to the power of x.
All right, we can do that. Let's bring that up. Let's see where this will take us then. We'll look at log e of 7 minus log e of 14 to the power of x is equal to 1. It's a good start. Why did Rango do that? What's the benefit of doing that? Why would I just bring the x up there? Is there any benefit to doing it? Now they have the same bases, and maybe we can use rule number 2 of log law. What's rule number 2 again, Joe? Very good. So it becomes then log base e of 7 divided by 14 to the power of x is equal to 1. All right. That's nice. It looks better than what we started off with. Our goal is still to find x. What do I do next now? How do I get x? X is in the denominator of a fraction, which doesn't make it look too nice.
Bring it to the top.
How do we bring it to the top?
14 to the power of negative 7 times 14 to the power of negative.
We could do that. Let's try that. It's all experimental. I'm really not guiding you at the moment. I'm just following what you're telling me. So here we go. Log e of, and everyone could have done it differently as well. We're just experimenting right now. So if we bring this 14 all the way to the top, which we use index law number 7, that essentially means 7 times 14 to the power of negative x. That's true. Nothing wrong so far. Everything's still correct. Our goal is still to find x. What's the...
Exponential, like you already changed it.
Okay. So we don't like this log. We can get rid of the log by doing the opposite of log. And what's the opposite of log again? Exponential. In this case, it'll be, since that's a log base e, it's exponential base e. So I'm going to go exponential, which means e to the power of whatever's on the left-hand side. And then whatever is on the right, I do the same. So e to the power of 1. Okay, it's kind of like how you've always been balancing the equation. Times 2 times 2. Then here I'm doing e to the power of, e to the power of. Yeah? E to the power of log base e will cancel out because they're inverses. You're left with 7 times 14 to the power of negative x is equal to e to the power of 1. We're getting closer. I can see the x there. What are we going to do now? What are we going to do? Anyone have a clue? Mia, what would you do next? Divide both sides by 7. That's the most obvious one there. That's times 7, so I can divide both sides by 7. 7 divided by 7 cancels out, and I now have 14 to the power of negative x is equal to e to the power of 1 is just e, so e on 7. E's Euler's number, by the way. That's about 2.71-ish. Okay. I still haven't found x yet. What do I do now? That's 14 to the power of negative x. You could turn it back to a fraction again. Okay, so it'll be 1 on 14 to the power of x is equal to e on 7. It's good. It's just exploring. Because again, it's all about problem solving, right? Doesn't really matter which way you approach it. I obviously would have approached it in a different way as well. Ryan, you got a clue?
I would just put the 4 to do 7 equals e 14 to the x.
I see. So you're saying times both sides by 7 to get rid of the fraction on this side, and then times both sides by 14 to the x, like that, to get rid of the fractions. So you end up with 7 is equal to e times 14 to the power of x. Yeah, not bad. Now we don't have fractions, less confusing. What do we do now? Still trying to find x. You could put it back into log, but I would probably, because we're trying to get x, we'll probably need to get rid of that times e there. So maybe I would divide e on both sides first. So I would get 7 over e is equal to 14 to the power of x. Now we can then say, how do we get rid of, remember this is exponential base 14. It's 14 to the power of x. So how do you get rid of exponential base 14? Log base 14 is just the opposite of that, right? So I could have just done from here, do log base 14 and do log base 14. Log base 14 cancels out, and you get x is equal to log base 14 of 7 on e. Not too bad. Okay, that is one way. I probably, from the beginning, I probably would have just literally moved this one across and then divide both sides by log e of 14. That's probably what I would have done. Just because we're just trying to find x, aren't we? So here, if it was log e of 7, it's a number. I don't know what that number is. But who cares? And this is minus x log e of 14 is equal to 1. So I probably would have just said minus log e on both sides. Minus log e of 7 on both sides. These cancel out. You get negative x times log base e of 14 is equal to 1 minus log e of 7. And then because we're just trying to find x, we'll just get, this is a times x, so I just divide both sides by negative log e of 14. Divide this side by negative log e of 14. And therefore x equals to 1 minus log e of 7 over log e of 14. That's me being lazy. If I didn't want to do anything else, yours obviously looks nicer than mine. If we went through all the algebra and you get log 14 base 14 of 7 on e, but there was nothing wrong with leaving that as my answer. Okay? Because I'm just trying to find x. And if you typed on your calculator, both of them should give you the same value. Okay? All right, let's try the next one. So that one, I just thought that was interesting. That's from 5G question 1C, how you would approach it, mainly because of that. There's a lot of numbers there. Okay, log e of 14 is a number and log e of 7 is a number. We just don't know what those numbers are. Okay, any questions on what I did or any approaches that you'd like me to clarify? Because that's what you do in 5G. Okay, yes. I divided both sides by negative, because that's a times by -1. So I said divide by negative log e of 14, and then divide this side by negative log e of 14. And I forgot the negative here. Thank you. So it should be, I guess if anything, it should be negative and positive there. Yeah, because negative becomes -1, and then negative becomes positive. Yeah. All right, let's try the next question. This one is very typical of, I guess, an exam type question, which you should be familiar now. I'm going to pause the video and give you some time to have a crack at this one. So this is a typical exam question, exercise 5G, question 4H. Have a go. How would you solve for x again? If it's exam type, likely there's a quadratic. See if you can find the quadratic in this question. I'm going to pause the video. This is the technique, which you'll find it's always going to be the same if this comes up in your exam the end of the year. Try to find that quadratic. That's 5 to the x. The aim is to make that 5 to the power 2x somehow a 5 to the x. What I said was let t, just because t is Fortran, t is equal to 5 to the x. And I said, well, 5 to the 2x is the same thing as writing 5 to the x squared, because we know that we can use index law number 3 times the two powers together. So by changing the 5 to the x and 5 to the x over here, I can replace them with the letters. It becomes t squared minus 4t minus 5, and suddenly you got a quadratic problem. Factorize the quadratic. That's a monic quadratic there. Base number or constant is 5, so I just took 5 and 1. Negative 5 plus 1 gives you the negative 4. And you should get t equals negative 1 and 5. Can I get a show of hands who got up to this step? Right, well done. That's 2 marks. Okay, so in an exam, there'll be 2 marks there. So you got a method, and then your answers of negative 1 and 5. Your third mark, if it's an exam question, is the clarification point. T, which is 5 to the power of x, well then t could either equal to negative 1, 5 to the x equals negative 1, or 5 to the x equals 5. What's the problem? We can't have any exponentials that is equivalent to a negative number, so you must tell them x is undefined, and then x equals 1, so therefore x must equal to 1. This is where your third mark comes in. Okay, so they're looking that you know the property that exponentials cannot equal to negative value. Hands up if you got that third mark. All right, well done. Very good. So that example there, 5G, is actually no different from this example, VCAR 2015, question 1, 7B, which you might have done already in one of the sheets I've given in the past. If you haven't, you can have a go with that one again, but I'm not going to do it again. That's a 3 mark, same idea. This one I do want to do because I want to see if you pick up on my error. So I'm going to do the wrong thing, and then you're going to pick up where I go wrong. Okay, so here we go. We've got an inequality. 0.7 to the power of x is greater than or equal to 0.3, right? So here we go. 0.7 to the power of x greater than or equal to 0.3. And then I say, all right, I want to get rid of that exponential base 0.7 because it's exponential right now. What I could do is I could do log base 0.7 on both sides. But let's say you weren't used to doing that and you only have log base 10 or log base e. So let's do this. What if I did log base 10 on the left? So whatever you do to one side, you do to the other. So I do log base 10 on the right. So far, so good. I then use log rule number 3. I bring this one down. And that gives me this new line. I have x multiplied to log base 10 of 0.7 is greater than or equal to log base 10 of 0.3. To find x, which is over here, this is what I need. So I need to get rid of times by log 10.7. And what I do is then I say, let's divide both sides, because that's the opposite of times, by log 10.7. And then I divide this side by log 10.7. Therefore, my answer must then be x is greater than or equal to log 10 of 0.3 over log 10 of 0.7. I've gone wrong somewhere. What have I done wrong? Whoops. I'll just record this bit. Be mindful of log, where is it again? Log base 10 of 0.7 is actually a negative number, so you have to switch the signs. Okay? Let's have a look at 2014. This is now a log problem, very similar to the first one, or not really similar to the first one, but again, you're using exponentials to solve this problem. I'm going to pause the video. Let's see what you got. Log of x minus 3. Let's start. So, what would I do? What would I do? I would probably bring both of the logs to one side and bring the 3 across. So I would have log base e of x minus log base e of root x is equal to 3. Using logarithmic law number 2, hands up if you got up to that step. Something like that. So we need to simplify the problem. Good. Next one. Get rid of the log. Do exponential on both sides. That cancels out. Or you can do the conversion, whatever you want to call it. I just think of a balance in the equation. X over root of x is equal to e to the power of 3. And then from here, note that x square root of x is the same thing as x to the power of half. Index law number 2, if you're dividing them, this has a power of 1. This is going to be a power of half. So really you're doing, what is x to the power of 1 minus half? Is equal to e to the 3. That gives you, what, negative half? Is that right? Oh, sorry, half. What am I talking about? All right, well, that's nice and easy. X to the power of half is equal to e to 3. So if x to the power of half is equal to e to the 3, remember, to the power of half is the same thing as square root. Or if you didn't know that, you could just do the inverse or the reciprocal of half. So if you times it, or to the power of 2 and 1, and do the same thing 2 and 1, these will cancel out nicely. So you end up with x is equal to e to the 6. Have I confused anyone in that step? Okay, so what I did here, for those who weren't sure what to do from this step here, because sometimes in exams it doesn't have to be half. It could have been 3 over 5, and you need to know how to get rid of it. So for example, if I gave you x to the power 3 on 5 is equal to e cubed, how do you get rid of that power 3/5? Yeah. So we know index law number 3, you can get rid of that by timesing the powers. But to do the powers, you have to you don't always have to square or cube. You can actually say, on the left, I'm going to do the power of 5 on 3. Whatever you do to the left, you do to the right. It's nothing wrong. Right? Who said we have to square it? It could have been cubed, it could have been a quarter. So I'm doing 5/3. But index law number 3 says you can multiply the powers together. 3 over 5 times 5 on 3 are reciprocal, so they're all going to cancel out to be 1 and 1, 1 and 1. So essentially you're doing an inverse, which is why when you're doing squares and square roots, why they cancel out. So if you did an x squared and you square root y, it cancels out. It's the same thing. You're just doing half times 2, just the reciprocal. Okay, so that's a tip. If you do get an exponential power that doesn't happen to be something you're familiar with, you can do the reciprocal to get rid of it. So all I did was here, I said since the power is a half, I said, well, to get rid of that power, I just do to the left-hand side to the power of 2 and 1, because that's the reciprocal. And then here I say do the power of 2 and 1. There's nothing wrong. Balance the equation. Multiply the powers together. Half times 2 gives you x to the power of 1. And this becomes e to the power 3 times 2, which is 6. It's an exam 1, so you don't need to know what that actual value is. But we know that Euler's number is about 2.71, so to the power of 6 must be greater than 0. So therefore, this works. Hands up if you got the same answers I did, even if you did a different approach. Okay, very good. Excellent. All right. That was exercise 5G. Now, 5H, there's only one problem I do want to do with you, and that's about it. And then we'll call that it for today. So let's fill in some notes. Flip over to your next notes, pass of your notes. Inverses. What are a couple of things I want you to note? When the question says find the inverse function, okay, if it says inverse function,